Hi, my name is Ben Clarke. I'm from the University of Oregon. Today, I'll be talking about developing and validating math interventions using the IES research framework. Let's go ahead and get started. So the goals of the presentation today are going to be understanding the process of IES grants, from development grants all the way up to efficacy and replication studies. And to do that, we're going to first delve into a little bit about understanding the scientific research base to find critical levers to ensure our research is of high quality. We're going to have a broader framework, thinking about curriculum development from a science perspective. And then as we get into more of the efficacy grants, we'll talk about exploring questions of impact. And lastly, we're going to dig deeper to answer questions that are relevant for school-based practice. First, the focus on mathematics, it's rooted in the research base, is really taken from a few longitudinal studies. We know that mathematics difficulties are persistent and quite difficult to remediate. The same as reading difficulties. So if we think about poor math performance in kindergarten, we know that that continues on into first grade, second grade, all the way up to fifth grade and later. And that early knowledge of the number system predicts functional numeracy up to 6 years later. The other key component to remember when we think about a focus on early math is this idea that early math difficulties have a clear and negative impact on student outcomes throughout later schooling, just as we found in the case of reading difficulties. And so like we had a shift in reading intervention to a focus on early intervention, we're going to have that same focus in mathematics to drive our work. So a couple of just broad recommendations when we think about early math intervention. One is obviously if we're going to help at-risk students, we want to be able to identify them earlier on in those trajectories. And instead of covering the whole content of mathematics, we're going to really focus in on whole number concepts and procedural fluency. And lastly, if we're going to be building interventions, we want to make sure that we think about the instructional architecture of our interventions so that we know that we use effective design principles that have been proven effective over time with struggling students. To do this, we're going to use what we call curriculum research framework. This was first proposed by Clements in 2007, and it centers on iterative cycles of development, field testing, and has three primary categories. The first is a priori foundations, where you're really delving into the research and theory behind what you're proposing to do, and you're engaging in sort of a review of the literature and pedagogy around teaching mathematics. The next is building learning models, and this is how you're going to be thinking about delivering the intervention to students, the types of prototypes, models that you want to be building for your interventions. And the last piece is what we traditionally think about as research supported by IES, and that's the evaluation piece. We'll use an exemplar to show that we're really thinking about those three stages: a priori, learning models, and evaluation, from the start of an IES grant, development grant, all the way to an IES efficacy trial or a replication trial. So to go a little bit more deeply into the curriculum research framework, categories, and phases, a priori foundations has really, again, that focus on theory, understanding and rooting your intervention into the current research or literature base, and again, thinking about pedagogy approaches. Then when we switch into the learning models phase, it's really consisting of one phase, which is developing prototypes, having cycles of feedback and revision with your end users, and refining those so that you come up with models that work for sharing the content that you want students to learn. The last piece is evaluation. And again, the initial phases of this are really focusing on taking those prototypes and testing them out with multiple users in multiple settings. So you're really thinking about the feasibility and the usability of the intervention that you're developing, making sure that it's usable in school settings by instructional assistants, by teachers, rather than something that's developed in a laboratory and only used by participants in the laboratory. Next piece is really establishing the promise of that intervention to improve student outcomes. And once you've established sort of feasibility, usability, and potential promise, then you move on to much more formal testing, which is efficacy and effectiveness. So to give an example of this process, I'm going to be talking today about fusion, or also sometimes known as whole number foundations, 1 for first grade. And this is a project that has been supported by the Institute of Education Sciences through both a development grant, 3-year development grant, and also a 4-year efficacy trial that was just recently completed. So as you see, we have quite a few people on our Fusion project staff. We have myself as the principal investigator, other PIs on the project. We have a broad curriculum and professional development team. Our curriculum and professional development team, we pull from teachers that have developed curriculum before and are helping us with that process, research and project coordination along with other field staff. So when we think about the curriculum research framework in Fusion, we first got a development grant, again, a 3-year grant, to support sort of reviewing the literature, thinking about what we wanted to cover in terms of the content. And we use this to engage in what we call brief learning trials. And this is in the first year of the project into the second year of the project, where we're taking small aspects of the curriculum or components of the curriculum that we're thinking about utilizing, and we're testing them out in school settings with teacher partners. We actually call them teacher researchers, and we engage deeply with them. So we would go out and test a component of the intervention. We would get feedback from the teacher researchers as they tested that component, and we would engage in a revision cycle. We'd go back out again, try it again. As we built this different components of the intervention, we started to piece those together into activities and lessons. And again, our teacher researchers would try those out in the field, and we would gather information about how well they worked or didn't work, and then we would engage in a revision cycle. The last part of the development grant is the evaluation piece. So the second year of the project, we start to gather information on feasibility and usability. So if we've designed a 30-minute lesson, which we aim to do with Fusion, we would go out and test it in schools and make sure it fit within sort of that 30-minute window. We would look at specific activities to see whether or not they could be implemented with fidelity. And we would collect information from our partners again about the feasibility and usability of what we had developed. The last year of the development grant, we actually run a pilot study. So we did this with local school partners, randomly assigning classrooms to treatment or control, and starting to collect student impact data to see whether or not the intervention had evidence of promise. Once we had completed that grant, that development grant, we went back to IES and got funding to run an efficacy trial to test whether or not the intervention worked. So it was primarily a grant focused on the impact of the intervention. Was it effective in moving student outcomes? Yes or no? But we wanted to delve a little bit deeper. So we started to ask questions about, does Fusion work, and with whom and under what conditions? And I'll give some examples of what that type of research looks like. So again, when we did this efficacy study, we wanted to test the extent to which the Fusion intervention improved the math achievement of students at risk for math difficulties. And the primary aim was to test the efficacy of the Fusion intervention in 120 first grade classrooms to examine both immediate and long-term effects of Fusion. We also had a secondary question that we were interested in, which was focused on what we call treatment intensity. So if you think about most multi-tier models of support or response to intervention, they're sort of premised on this idea that as the intensity of the student's needs increases, you also increase the intensity of your intervention. And so we tried to build in a manipulation to our intervention where we had a less intensive version and a more intensive version. And we did that by manipulating group size with the idea that a smaller small group would be more intensive than a larger small group. So the Fusion curriculum itself consists of 60 small group lessons. Lessons are designed to be around 30 minutes of delivery. And we had either 2 or 5 students per group. So that was that manipulation that I talked about earlier. And the curriculum was designed to be delivered over the course of 12 weeks. So 5 lessons per week for about 12 weeks. In reality, it usually took 13 to 14 weeks because of school days being missed or other reasons beyond our control. So the first thing that we wanted to make sure of is that we had alignment with documents that are currently guiding content coverage in mathematics. And that's most commonly the Common Core State Standards in Mathematics. So you can see in grade 1, we're really focusing on operations and algebraic thinking. And then, of course, number and operations in base 10, really emphasizing the importance of the base 10 system. We also made sure when we were thinking about our content that we wanted the students to engage in mathematical practices that are critical for them becoming sort of mathematical thinkers and good practitioners of mathematics. Across the lessons, as you can see, the 60 lessons on the top, we divided the program into quarters, and each quarter covered content. The content, of course, became continuously more difficult as students progressed through the program, but we really wanted to make sure that we had a coherent scope and sequence so that as students encountered new content, they had the prior background knowledge that they needed to access that content. And we sort of systematically moved through from less advanced content to more advanced content, to where at the end of the curriculum, they were engaging fully in first grade mathematics. There are 4 content strands in Fusion. Primary focus was on this idea of understanding place value and becoming very familiar with the importance of place value, the concepts behind it, and doing that with numbers all the way up to 100. We had a focus on number combinations, including strategies for addition and subtraction facts. So first teaching underlying strategies and concepts of addition and subtraction before we moved into procedural fluency with those number combinations. We also encountered multi-digit addition and subtraction for students. And lastly, we wanted to have plenty of opportunities for students to engage in problem solving as they work through the curriculum. So those problem solving elements included working with word problems and working in groups to solve a range of problems. One thing that we did that we felt was really critical was to make sure that we had a focus on number properties, but also math vocabulary and discourse. If you observing first grade classrooms or lots of different math classrooms, sometimes you run into this issue where there's not very much intentionality around how these activities are designed. So the students that engage in discourse around mathematics are usually the students that already know the mathematics and don't necessarily need the practice of engaging in the discourse of mathematics. So we were very intentional in terms of how we designed our activities to ensure that all students had the opportunities to engage in that discourse around mathematics. We felt that was critical for a number of reasons. One of the reasons was that we had a number of students in our studies that are English language learners, and we wanted to make sure that their needs were supported as they went through the program. The other cornerstone, besides the focus on whole number content, was really this idea of explicit and systematic instruction. And so this is probably the most well-researched area in all of mathematics in terms of the research base. And so we know that for students that are struggling in mathematics or students that have learning difficulties in mathematics, using an explicit and systematic instructional approach is critical. And so really what we're trying to do is to focus on the big ideas of mathematics and teach them in an efficient and effective manner. And so we try to use really clear and consistent language. We try to use a set of math models that we think clearly illustrate the concepts underlying the mathematics. And then we eventually try to build those up into students having procedural skills with a range of mathematics. In the Fusion program, we use lots of different types of models, but again, we tried to have a select amount of these so that they could learn both the how and the why of these whole number concepts and skills. And typically we would use what's called a concrete representational abstract sequence. So first, students have the opportunity to work with concrete manipulatives, then move them to representations of those math concepts, and then finally the abstract symbols that are inherent in mathematics. Here's an example lesson. We try to structure the lesson so that each one had a consistent structure, primarily so that if a teacher or an interventionist or an instructional assistant was picking up the curriculum, after they taught 2 or 3 lessons, they would sort of develop a flow of how the lessons went. We always started out by listing out the overview of the lesson, which with the activities, the warm-ups, the wrap-ups, and the activities in between. We listed the strand under which they were occurring. And then we had a quick little box that showed what teacher materials and student materials would be needed to complete the lesson. Because the teachers were teaching this to small groups of students, we wanted to have a couple of cheat codes that they could quickly glance at the lesson and understand what was being required. So we had things like group responses, checks to monitor for understanding and opportunities for math talk for students to engage in. And then you can see once the lesson started, it was lightly scripted, and you worked through the lesson until you came to the conclusion. And again, this structure was repeated for each lesson so that an instructional assistant picking this up could get used to the structure and format and move through the lesson without any problem. So underlying this efficacy grant, the development grant and then the efficacy grant, was our theory of change. And our first component, again, is that focus on whole numbers. And then the second component is that focus on the instructional design, that explicit and systematic instructional approach. We call that the instructional architecture. We felt that if those two themes were hit upon, that we would increase the quantity and quality of teacher-student interactions. We would target both procedural fluency and conceptual understanding. And we see those two pieces as being mutually reinforcing of each other. And that eventually, if students were successful on sort of our proximal outcomes, that would transfer to our distal outcome, which would be student math achievement. If you see on the far left of the screen, you can see that we have a box around group size. And again, that was the idea that we could intensify the intervention by decreasing the group size such that we would have a greater quantity and greater quality of teacher-student interactions. So for our study design, we used what was called a randomized block design, blocking on classroom. And essentially what this meant is that we screened all the students in the classroom. We identified the 10 lowest, and then we randomly assigned them to one of three conditions: a control condition, which was business as usual, or a treatment condition, which was fusion in a small group of 2 students, or fusion in a large small group of 5 students. So we had 3 students go to control, 2 students go to the small group, and 5 students go to the large small group. So our first 2 years of the project, we were in 3 school districts in suburban Oregon. In years 3 and 4, we were in urban settings in Boston, Massachusetts, and then Portland, Oregon. But for this first 2 years, we were again in suburban Oregon, and we were working in 53 classrooms. Across those 53 classrooms, we screened a little bit over 1,000 students, and we screened them on an early numeracy CBM called Aspens. It had students do things like identify missing numbers, compare magnitudes to see which magnitude was greater, and identify numerals. We got a score on that. If they fell into the strategic or intensive range, they were eligible for the intervention. And again, we randomized those students into control, fusion large group, or fusion small group. So for our interventionists, we didn't have University of Oregon staff deliver the intervention. We actually had school district employees, instructional assistants, deliver the intervention for us. We chose to do that because we wanted to make sure that we were using individuals who would typically deliver interventions in school settings, and often that's an instructional assistant. And so we worked with instructional assistants. We provided an initial training in the fall of 4 hours. And we focused on the content in book 1, which is the first half of the curriculum, which is lessons 1 through 30, really talking about generally effective instructional practices in mathematics. And we tried to have an engaging Ph.D. session where our participants got to practice the lessons, got feedback from coaches, and support in terms of developing their skills and delivering the intervention. And then we had a mid-program training that occurred right around when they were going to start the second half of the curriculum, which is lessons 31 through 60. At this point, we were providing feedback on their delivery of the curriculum to date, troubleshooting any issues that had arisen, thinking proactively about what we wanted to do in the second half of the intervention. And again, we had lots of opportunities for the instructional assistants to focus on lesson prep and practice with feedback from our team. We had an array of measures that we collected as part of this work. Aspens, Profusion, Easy CBM, and TEMA are all sort of math outcome measures, which is typically what you're going to see in an efficacy study. But we're also interested in, in answering those questions about for whom and under what conditions the intervention works. So we collected things like the head, toes, knees, and shoulder, which is a measure of executive functioning, implicit theories of math ability, which focus on how students think about approaching tasks in mathematics, a child behavior rating scale, We collected information about what was going on in the core instruction as part of that tier 1. We collected lots of different instructional logs to document what interventions were being provided above and beyond Fusion, what was happening in the core classroom. And last, we did a lot of observations of Fusion itself. So thinking about fidelity of implementation, treatment intensity, and the overall quality of the instruction that was provided. So the two research questions that we had that I alluded to earlier, one, what was the overall impact of the Fusion intervention as compared to business as usual? And then the second one was there a differential impact on student outcomes between the 2-to-1 Fusion group and the 5-to-1 Fusion group? So for overall impact, you can see that we had generally positive impact across our measures. On 2 of the 3 outcome measures, we had a positive significant outcome, Aspens and Profusion. And then we had a positive non-significant outcome on the TEMA, which is another test of early mathematics. What we're really interested in was the second question that was focused on group size. And one of the things that's interesting is that we had done a similar study with a kindergarten math curriculum we developed called Roots. And when we tested Roots, we found that Roots had a positive impact on student outcomes, and that impact did not vary at all by group size. So students had the same impact on their math outcomes if they got Roots in a 2-student small group or a 5-student small group. So we had theorized that we'd see this pattern repeat itself when we conducted essentially the same type of study with first grade and with our first grade curriculum Fusion. Well, we actually were wrong, and we found that there was a difference by group size, and that students that were in the 2-student small group compared to the 5-student small group had greater outcomes. So if you're thinking about sort of implications for service delivery models, you might come away with thinking in first grade it's critical that you think about group size when you think about intensifying your intervention, whereas our findings in kindergarten showed the exact opposite, which was rather interesting for us. So just as sort of a overview, we've done this curriculum development process repeatedly through our IES research grants. We have listed here some of the curriculum that we've developed with IES and also National Science Foundation NSF support. So we've developed a core kindergarten program called ELM with 120 lessons covering geometry, measurement, whole number. And then we've developed intervention programs, Roots, Fusion, and Flex, which are focused exclusively on whole number. And then we've also taken the whole number content from our paper and pencil interventions and transferred that to tech platforms. So Numbershire and KinderTech, targeting kindergarten and first grade content. And lastly, we've started to extend our work into rational numbers with the PAR intervention, promoting algebra readiness, which is really targeting sort of the precursor skills to algebra and with a strong focus on rational numbers. So that's targeting sort of 4th grade, 5th grade, 6th grade, and students that may need assistance with those skills. So besides developing these curriculum, when we start to think about studying these curriculum, we're really asking questions that go beyond impact, which is whether or not we had an impact on student outcomes. We're really focusing on lots of secondary research questions that we think are of high interest to the field. So we are analyzing our studies for impact on English language learners. We're looking at questions around moderation. So are there variables that influence the degree of impact that your intervention might be having? We look at features of core or tier 2 that might be interacting or driving student outcomes. And we're starting to investigate, can we maximize intervention timing to increase student outcomes and increase their access to the core instruction? So I'm going to give a couple examples of those just from various research studies that we've done so you can get a sense of the scope of research that we're doing with our IES funding. English learners, I won't belabor the case too much, but we know that ELs in the US and Spanish-speaking ELs are among the fastest growing demographic population that schools are serving. We know that there's inherent challenges for these students because they face the double demands of not only learning a new language, but also learning the content that they're typically expected to be learning in schools. And so in the case of early mathematics, there's still demands on learning whole number systems, learning rational number systems at the same time that they're also learning the English language. And unfortunately, there's relatively few rigorous studies of math interventions for ELs. In 2016, there was a review of the research literature. We found that there were 0 studies of math interventions with ELs. That's increased a little bit, but not nearly to the amount that it needs to. So with one of our projects, this is the Roots intervention that I discussed earlier. This is kindergarten math intervention targeting whole number concepts. We did a secondary analysis of our data set to look at the impact on students who were ELs. And this is the number of classrooms we had was 138. We ended up with 200 English learners that were in our treatment condition and 95 in our control condition. You can see the range of languages that were spoken. So in terms of overall impact, we had a positive significant effect size on all 4 of our outcome measures, the TEMA, the number sense brief, Aspens, and RAINS. And interestingly enough, when we compare the impact for ELs compared to non-ELs, we found that our impact on math outcomes was actually greater for our EL sample. And we attributed that to some of the design of the curriculum. So when I talked earlier about building in opportunities to work with math vocabulary and to engage in math discourse, we think that intentional focus in the curriculum design had an impact on the outcomes that we had for the EL population. We also asked 2 secondary questions, and these are these moderation questions. So we looked at whether or not impact for ELs varied by the amount of student math skill at the start of the intervention. So there's been different theories that have been presented about moderation by initial skill, with some folks noting that students that have greater deficits may gain more because they have more room to grow. Other folks suggesting that if students are not severely at risk, perhaps they can access the content in math interventions better than students that have severe deficits. So when we examined that question here, we found that regardless of the initial skill of our participants that were English language speakers, that the intervention had the same impact. It worked equally well across the range of initial skill. The other interesting thing that we were interested in is looking at English language proficiency. And here we found that students that had lower levels of English language proficiency at the start of the intervention actually had a stronger response to the intervention than students who had stronger English learner skills or English language skills. And so again, that has some implications for thinking about the design of the curriculum and how we might best utilize it. Other types of questions that we're interested in are really examining sort of the interaction between Tier 1 and Tier 2. So we had a Tier 2 intervention, again, Roots, and we went in and we rated the quality of the Tier 1 instruction that students were receiving to see whether or not that influenced the impact of our Tier 2 intervention. And what we found is that in classrooms that had lower rated Tier 1 quality, we had a greater impact for our intervention. So in a way, this makes sense, right? If you have really strong Tier 1 instruction, you may have less of a need for Tier 2, and Tier 2 may have less of an impact on student outcomes. But if you have lower quality Tier 1 instruction, Tier 2 becomes even more important, and you can have larger impacts. So again, an interesting way to think about the interaction between our tiered models of core instruction and intervention. The last study that I'll talk about is one that we just completed, and I think this one has interesting implications. Again, this was with Roots. This was a study that was conducted in El Paso, Texas. And we were really interested in this idea around intervention timing. Is there a time period where we can deliver an intervention and maximize its impact on students? So we took students within classrooms. We identified the 9 lowest students in a classroom, and we randomly assigned them to one of 3 conditions: a control condition, where they got business as usual, 3 students; a Roots that was delivered at the beginning of the year, so in the fall; or a Roots condition that was delivered in the middle of the year, so starting in winter. And you can see here on the graph that from fall to winter, our roots middle of the year and our comparison groups looked essentially the same. And that's because they were getting business as usual. Whereas our students that got roots at the beginning of the year, from fall to winter, had a drastic increase in their scores over time, such that in the winter they were outperforming both of those groups. Now, at that point, those students stopped getting the intervention and went back into core instruction. So you can see from winter to spring, they still grow, but not as at the same rate as from the fall to winter. Whereas the students who got the intervention at the middle of the year, they start to take off and they start to pull away and separate from the students that were just getting business as usual. So it's interesting in that we can think about maybe we want to start timing our interventions for earlier in the year. And then instead of stopping the intervention, or when the intervention is done at the end of the 50 lessons or 60 lessons, that we would continue to provide some support to those students so they continue on their rate of growth, as you see here. So obviously, we do lots of research in the area of early mathematics. So for more information about Fusion or any of our math intervention research, we post the studies that we've done. We do overviews of our projects, lots of interesting information for thinking about how best to support students with math difficulties. You can go to our web address there that lists our research sites. And then for any of our research studies that show promise and efficacy of our developed products, we do make those available to school partners, and that's at the second web address. Thank you for your time, and I'll be taking questions in the chat, I guess. Hi, everybody. If you've got a question about the presentation, go ahead and place it in the chat if you like. The structure of the IES grants is relatively unique in that they really try to funnel you from initial work in developing an intervention all the way up to thinking about the replication and scalability of your interventions. And so it's a long process. Some of these projects that we've been working on span 10 to 12 years, from initially writing a grant, hoping to get funding, all the way up to sort of doing full scale replication studies of an intervention. I hope everyone is enjoying the IES Math Summit. Like I said, feel free to email me if you have any questions directly. Again, that's clarkeb@uoregon.edu. And please feel free to reach out. There's also the web addresses and the presentation are available through the IES Math Summit. And take care and enjoy the rest of the day. Thanks.